Hello, the following video is to help the audience to get a basic concept and understanding of parallelization and applications. This video is credited by Valdemir Adamor, Kevin Campos, Paul Zajac, Joseph Martinez, and Armando Borges. What is parallel programming? The general concept, parallelization, is a technique that divides a program into separate components to run in parallel that can be independently solved at the same time by discrete computing resources. These components or result are combined in a final solution. And these components can be such as things as threads of a specific process or application, typically done in a system with multiple processors. Order of execution should not matter for parallel programming, as all threads and components are added together for that final solution. We begin by indicating specific concepts and types of parallelization and applications. First one is data parallelism, where simultaneous execution on a multiple cores of the same function across the elements of a data set, where each processor works on their section of the data. It is the concept that you have a lot of data that you want to process, for example, perhaps a lot of pixels of an image, or perhaps you have a whole lot of payroll checks to update. Taking that data and dividing it up among multiple processors is a method of getting data parallelism. This is an area that supercomputers have excelled at for years. It's a type of problem that is pretty well understood, and more emphasis has been put on data parallelism in the past than on task parallelism, which is the next concept. Task parallelism is a simultaneous execution on multiple cores of many different functions across the same or different data sets. Multiple threads or processes from different transactions can be executed concurrently. Task parallelism, on the other hand, is where you have multiple tasks that need to be done. So perhaps you have a large data set and you want to know the minimum value and you want to know the maximum and average volume of that data. This is a rather trivial example, but you could have different processors each look at the same data set and compute different answers. To task parallelism, it's a different way of looking at things. Instead of dividing the data and doing the same work on different processors, in task parallelism, what you're doing is dividing up the task to handle that specific problem. Next concept is pipeline parallelism. It's a set of data processing elements connected in series, where the output of one element is the input of the next element. The elements of the pipeline are often executed in parallel or in time-sliced fashions. In that case, some amount of buffer storage is often inserted between elements, but each buffer and storage use those elements and compound them over to the next process. Disadvantages: pipeline parallelism is not that good of a choice if degree of parallelism is needed and is high volume. Useful with small number of processors, so a big computer system with multiple processors probably will not be very useful with pipeline parallelism. Not all operations can be pipelined, and it cannot expect full speed up of that process. Now, we do have coming videos that will help explain processes in a more understanding way with materials that you can use around you or at home and should help with comprehending these concepts and these type of parallelization. Now, thank you for watching, and I hope you enjoy the next videos.
And then the student ID was 3750, and then her drop was 84.40. 84.
Data parallelism refers to scenarios in which the same operation is performed concurrently. Each process does the same work on unique and independent pieces of data. Test parallelism. Each process performs the same functions but do not communicate with each other, only with the master process.
System 1 loaded.
Pipeline parallelism. Each stage works on a part of a solution. The output of one stage is the input of the next. Note: this works best when each stage takes the same amount of time.